Now here we are having a problem on coordinate geometry. ABCD is a rhombus with diagonals AC and BD intersecting at the origin on the XY plane. The equation of the straight line AD is x plus y is equal to 1. What is the equation of BC? Now I just draw a rough diagram for you. Here we are having the rhombus, that is ABCD. Diagonals are AC and BD and they are intersecting each other at origin, right? So this is suppose A, C, B and D. This is origin. Now the equation of straight line AD is x plus y is equal to 1. So this is what x plus y is equal to 1. Obviously this line is parallel to this line, that is AD is parallel to BC. And among the options we are asked about in the question we are asked about equation of BC. That means among the options we have to choose a line that is parallel to x plus y is equal to 1, right? Now if we see in the options, C is the same line, so incorrect choice. X minus y is equal to 1 is not the line that is parallel to this. If we talk about the parallel lines, I just go for a quick recap over here. Suppose the two lines AX plus BY plus C is equal to 0. I mean A1, B1 and C1, and the other line A2X plus B2Y plus C2 is equal to 0. Then the condition for parallelism is A1 by A2 should be equal to B1 by B2, but that should not be equal to C1 by C2, right? So here you can see A1 by A2 is 1, but B1 by B2 is minus 1. So this line is not parallel to this line, but this is actually a perpendicular line to this. So this is incorrect. So we are left with x plus y is equal to minus 1. Obviously this and this, the length from the origin will be same, obviously. So x plus y is equal to minus 1 will be the correct choice for the equation of BC, right? You need to understand, or you need to keep this concept in your mind, right? Otherwise there is no paperwork required at all. Okay, now let's see this problem. In the above diagram, ABCD is a rectangle with AE is equal to EF is equal to FB. What is the ratio of areas of triangle CEF to that of the rectangle? Friends, very easy problem. No paperwork is required at all. Just wait for a moment. See, here I have drawn a line that is suppose FX, right? Now FXBC is a rectangle, right? And FC is diagonal of this rectangle. Now this diagonal will divide this rectangle into two equal parts, right? That means area of FBC is what? Half of that of this rectangle FBCX. Getting my point? I repeat, FBCX is a rectangle, FC is a diagonal. So this diagonal will divide area of FXCB into two equal parts, right? That means area of triangle BFC, area of triangle BFC will be half of this rectangle, isn't it? Area of triangle BFC is half of BFXC. Once you are clear, you don't have to write the steps. As of now I am writing it for you, otherwise no paperwork is required, right? Now area of triangle BFC is half of this rectangle. Now this portion, that is BF, is actually 1/3 of AB, isn't it? BF is 1/3 of AB. That means area of this rectangle, that is BFXC, is 1/3 of the entire rectangle. Okay, that is 1/3 of ABCD, right? That means what is happening? Area of BFC will be 1/6 of ABCD. Okay, area of BFC is 1/6 of ABCD. Now in case of BFC and in case of CFC, there is no difference between their areas, because the length of the base is same, because EF is equal to FB, and the length of altitude in both the cases is also same. So area of CFE is equal to area of BFC, right? So precisely it is 1/6 of the entire rectangle, right? You just have to understand the concept, no paperwork is required at all, right? I just go for a quick recap. The space is 1/3, that means the area of the rectangle will be 1/3 of the entire rectangle. Out of that, the area of this triangle will be half of the this rectangle, that means the area of this triangle will be 1/6 of the entire rectangle, right? And in case of EFC and CFP, area will be same because the base length is same and altitude is same, right? Definitely shape is different, but that doesn't matter, right? We concentrate upon base and altitude. So in both the cases they are same, right? So what is the ratio of areas of a triangle to that rectangle is 1/6. Okay. Now let's see this problem. Two sides of the plot measures this and angle between them is a perfect right angle. The other two sides is we have to find out the area of the plot. Very simple problem. Now what is happening over here? This is a right angle triangle and this is also, I just draw a perpendicular over here. Now we have to find out the area of this figure. The problem has become very simple for us now. This is a right angle triangle. This is 24, this is 32, this is 8 into 3 and this is 8 into 4, right? That means it is 3, 4, 5 Pythagorean triplet, right? So this is 3, this is 4, that means this must be 5 into 8, right? So this must be 40. Now further, this is an isosceles triangle. So this entire length is 40, that means this length must be 20. Now this is 20. Now this is 5 into 4, this is 5 into 5, that means this must be 5 into 3. Again Pythagorean triplet, right? So this must be 15. Getting my point? Now area of this triangle will be 24 into 32 by 2, right? 24 into 32 by 2, right? Area of this triangle will be a half base into altitude. So base is 40, altitude is 15. So, and by 2. So it's 20. So that's 320 plus 64, that's 384 plus 300, 684, right? As simple as that. You must be knowing that if 3, 4, 5 are Pythagorean triplets, so 3x, 4x, 5x will also be Pythagorean triplet provided x is a positive integer. Okay, the same funda I have used over here. Now here in triangle DEF, points A, B, C are taken on DE, DF and EF respectively, such that EC is AC and is equal to AC and CF is equal to BC. Angle D is 40 degree. We have to find out angle ACP, that is ACP, that is this angle. Maybe it is X. Similarly, I assume this angle to be Y. Now this is X plus Y. So this is an actually exterior angle. So sum of these two, that is this and this, must be also X plus Y, right? Now this angle and this angle, both of them are same, right? This angle and this angle, both of them are same because the lines, line segment are of equal length. That means this angle and this angle is same. Their sum is X plus Y. That means X must be equal to Y, obviously. So we can assume this angle to be X. Now this is 40, this is X. That means this angle must be 180 minus 40 plus X, right? So this angle is 180 minus 40 plus X. That means this angle should also be same because this line and this line is also of the same length. That means 2 times this angle plus this angle, that is Y, or we can say Y is equal to X, that's 180. That is sum of the 3 angles of the triangle, right? So it's 2 into 180, that is 360 minus 80 minus 2x plus x is 180. So x is equal to 360 minus 260, that means 100, right? So this angle must be 100 degree. Okay, I hope you are clear. Now friends, let's see this one. ABCD is a rectangle. The area of isosceles right angle triangle ABE is 7. EC is 3BE. EC is 3BE. The area of ABCD. Very simple question. We have just discussed the concept that if I drop a perpendicular from this place to over here, so I'll be getting a new rectangle, and the area of this rectangle will be double of this triangle, right? So area of this triangle is what? 7. So that means area of this rectangle will be 14. Now this base, the BE is actually 1/4 of BC, right? Because ratio BE is EC is equal to 3BE, that means BE is 1/4 of BC, right? That means the base is going to be 4 times. That means the area will also be of the 4 times because the height is same, right? So area of this rectangle ABE, suppose this is P, so area of ABEP is double of 7, that is 14, and the length of BC is 4 times BE, that means the area of DA will be 4 times of 14, that is 56. So no paperwork is required at all. Okay. Now friends, let ABCDEF is a regular hexagon. What is the area of the triangle ACE to that of hexagon ABCDEF? I draw a rough sketch. Wait for a moment. Now here I am having the hexagon ABCD, D, E, and F. Right? I have to find out the area of ACE. Now you know that a regular hexagon is a combination of 6 equilateral triangles that you can very well see. I have drawn these purple lines over here. So these 6 equilateral triangles are there, and I am interested in this ACE, right? So what I have done, you can see the parts over here, and all the parts are having equal area. All the parts are symmetric and they are having equal area. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts, right? So this hexagon is divided among 12 equal parts, right? Now out of these 12 parts, this triangle, that is triangle ACE, is having 1, 2, 3, 4, 5, 6 parts, right? So in all 12 parts, out of this 12, 6 parts are in this triangle ACE. That means area of triangle ACE is 6 by 12, or I can say 1 by 2 of this hexagon, right? So no paperwork is required if you are conceptually clear about it. And what is the concept? That the regular hexagon is divided among 6 equilateral triangles, as we can say. See over here, I have drawn these purple lines over here, right? And we are interested in triangle AEC. Okay, I hope you are getting me. Now, in the figure not drawn to scale given below, P is a point on AB such that AP is to PB is 4:3, PQ is parallel to AC and QD is parallel to CP. In triangle ARC, angle ARC is 90 degree, and in triangle PQS, PSQ is 90 degree. The length of QS is 6 centimeter. We have to find out the ratio of AP is to PD. Now friends, before I try this question, I would like to share a theorem with you. Just wait for a moment. See friends, here I am having a triangle with me. Now this is suppose triangle ABC, right? Now this line, suppose this is PQ, and PQ is parallel to BC, right? So whatever the ratio of AP is to PB will be there, the same ratio will be AQ is QC, right? If it is 1:3, then this will also be 1:3. If it is X is to Y, this will also be X is to Y. That is the property of similar triangles, right? And I can just explain you. Suppose this is angle X. Now this PQ is parallel to PC, right? That means this angle will be equal to this angle. That means this angle is common between APQ and ABC, and this angle is equal to this angle. So we can say AA similarity, that is angle similarity. That means triangle APQ is similar to triangle ABC. And if two triangles are similar, their sides are always in ratio. That means AP by AB is equal to AQ by AC, right? And the third side is PQ by BC, right? So whatever the ratio, this breakup is there, the same breakup will be there. This is the simple concept of similar triangles that you might have studied in your grade 10, right? The same concept we are going to apply over here in this question, right? Now just see carefully. Here AC, PQ is parallel to AC. This PQ is parallel to AC. And the ratio of AP and PB is given to us as 4:3. I assume it to be 4A and 3A. That is AP is to PB, that is 4:3. That means BQ and QC ratio will also be the same, that is 3:4. So this is 3A, this is 4A, right? I'm sorry, A I have assumed over here, so it will be, the ratio must be same, but the length may be different. So 3B and 4B. Now you can clearly observe this triangle CPB, right? In this triangle CPB, this line QD is parallel to PC, right? That is given to us, QD is parallel to PC, right? That means the ratio 3B is to 4B, the same will be BD is to DP, right? BD is to DP. I assume it to be 3C and 4C, right? Now we have to find AP is to PD. So AP by PD. Now AP is what? That's 4A. PD we have to calculate from here. 4C plus 7C. 7C is equal to 3A, right? That means C is equal to 3A by 7. That means 4C is equal to 12A by 7, right? And 4C is actually what? PD. So I just write it over here. 4C is 12A by 7. A is cancelled. This is 3. So the ratio is 7:3. As simple as that. So very simple concept of similar triangle we have used over here to solve this problem. And similar triangle you have studied in your grade 10, right? So I hope you are clear. Now friends, let's try this problem. Here AD, CD and BC. AD, CD and BC. And all of them are of equal lengths, and angle BCE is 96 degree. And we have to find out angle DBC. DBC, that is this angle. Now if this angle is X, this angle must be X, right? Now this is what? The exterior angle. So that is X. That means this angle plus this angle must be X, and both of them are equal. So that means it must be X by 2. That is, this angle must be X by 2. And this angle is actually 180 minus 2x. So X by 2 plus 180 minus 2x plus 96, that is this complete angle. This is X by 2, this is 180 minus 2x, and this is 96. That should be equal to 180, because this, so the straight line, so the complete angle should be 180, right? So 3 by 2 X is 96, so X is 64 degree, as simple as that, right? A simple exterior angle property of a triangle we have used over here, right? Further, you might have studied this property of triangle in your 7th or 8th grade. So very simple question, friends. I am sure you are clear. And believe me, this is from CAT 2003. So easy questions are also asked in CAT, right? You just have to have confidence in yourself, and your basics must be strong, right? The basics here I'm talking about your grade 7, 8, 9, 10 standards basics. Okay. Now let's see this problem. In the figure given below, A, B, C are 3 points on a circle with center O. The chord BA is extended to a point T such that CT becomes tangent to the circle at point C. Angle ATC is 30 degree. Angle ACT is 50 degree. Then the angle BOA that we have to find out. Now friends, you might have studied about the second tangent theorem in your grade 10, that is alternate segment theorem, right? Here you can directly use that theorem, as well as I can show you the proof of that theorem also. Just wait for a moment. Now here I have drawn this A, the C, or suppose this is maybe P, right? I have drawn diameter CP, right? That is passing through O, right? Now this diameter CP, that means this angle must be 90 degree, right? That is angle, and angle in semicircle is always 90 degree, right? So this angle must be of 90 degree. Now this OC is perpendicular to the tangent. Obviously this is, so that means this angle must be 90 degree. Now this is 50 degree, that means this part is of 40 degree, right? Now if it is 40 degree, so we can see in triangle PAC, this is 40, this is 90, that means this must be 50, right? Now friends, just observe carefully. We have a segment AC over here, right? Now in this segment we have an angle APC as well as angle ABC, right? APC, this angle, and ABC, right? So angles in same segment are always equal, right? So this angle is 50 degree, that means this complete angle will also be of 50 degree, okay? Now if we talk about triangle BTC, right? Triangle BTC. This angle is 50, this is 30, that means 80. That means this entire angle should be of 100. Now this is 50, this is 40, that means this must be 10, right? Now this angle, this complete angle is 50 degree, right? In this segment BA, this angle that is being formed at the circumference will be half of the angle that is formed on the center, at the center, right? So this angle is 50 degree, that means this angle must be 100 degree, right? So to solve this question, you need to be clear with 2-3 theorems based on circles, right? I have already provided the theorems related to circles and triangles in your this basic notes, so you can refer the same from there also, and you can watch the video of basic theorems and of circles and triangles as well, right? In that session I have already explained the basic theorems related to circles and triangles which are necessary for various competitive exams, right? So I hope you are clear. Now here we have one more problem on geometry. In the figure below, a rectangle ABCD is inscribed in the circle with center at O. The length of side AB is greater than that of side BC. The ratio of area of circle to the area of rectangle is pi is to root 3. The line segment DE intersects AB at E such that angle ODC is equal to angle ADE, right? Now what I do is I just complete this and I draw a line over here that's perpendicular, right? Now this angle is X as it is given. This angle is equal to this angle, that is angle ODC. ODC is equal to ADE, this angle, right? Now this line is parallel to this line, that means this angle will be equal to this angle, right? Now we can suppose I assume this point to be P. Now triangle OPB will be parallel, will be similar to triangle DAE, obviously, right? Because one angle is x, that's same between the two, and one angle is 90 degree. So we have A similarity, that is angle similarity. That means if the two triangles are similar, then their sides are in proportion. That means BP by OP is equal to the side opposite to x is OP. Here the side opposite to x is AE. That's AE, and the other leg is AD. Right? So BP by OP is equal to AD by AE. Now we assume the length and breadth of the rectangle is L and B, right? That means this is L and this is B. Now this is what the radius of the circle. This is OB is the radius of the circle. That means BD is diameter of circle. So that's L square plus B square is equal to 4R square, right? And we are given the ratio of area of circle to rectangle. So pi R square is pi k, and L into B is root 3k, right? That means R square is equal to k and LB is equal to root 3k. So instead of R square, I write k over here. That means L square plus B square is equal to 4k, and LB is root 3k. So I divide it by LB. LB plus L by B plus B by L is 4 by root 3. So that is actually 3 plus 1 by root 3, or we can say root 3 plus 1 upon root 3. So L by B plus B by L is root 3 plus 1 upon root 3. That means L by B is 1 upon root 3. Okay. Now if we see over here, BP is this, that is half of the length, and OP is the half of the breadth. So this is actually L by B, and L by B what we have got, that is 1 by root 3, right? So that is AD by AE ratio will be 1 by root 3, right? But since it is given over here that the length of side AB is greater than side BC, that means actually L by B is not 1 by root 3, but B by L is 1 by root 3. So instead we'll be having B by L as 1 by root 3, that is AE is to AD. Okay, I hope you are clear. We just have used the concept of similar triangles over here. I hope you are clear. Friends, 2-3 more conceptual problems I am taking in this session. Maybe or may not be options are available over there, but you need to understand the concept, right? So that's why I'm taking these problems. So let's take the next one. Yeah, here I am having an interesting problem on geometry. In a right angle trapezium, lengths of parallel sides are given as A and C. What is the radius of the circle inscribed in the trapezium? Now I am having this trapezium over here. It's right angle, and the length of this and this is given as A and C to us. So I assume this to be A and this to be C, right? Now we have to find out the radius of the circle that is inscribed in this trapezium. Now one more important thing over here that you should note, that in a trapezium, or maybe if we talk about any quadrilateral, sum of opposite sides should be equal, right? Sum of opposite sides should be equal if it inscribe a circle. Okay, that is an important property. Now how do I solve this problem? I will use coordinate geometry over here. I assume this to be 0 0. I assume the radius of this is r, so the PQ length will be 2r. So this will also be 2r because PQ is parallel to AD. Okay, so this is 2r, so this is also be 2r. Now the coordinates of this point will be 0 and 2r, the y coordinate, because the height is 2r. Similarly over here, the coordinate of this point, since this length is a and this is x-axis, so coordinate of this point will be a0 and coordinate of this point will be x coordinate is c because this length is c, and y coordinate will be 2r. Okay, now we got the coordinates of all the four vertices. Now we are going to apply this property that sum of opposite sides should be equal if it inscribes a circle. Now since the circle is inscribed, that means sum of this length plus this length is equal to this length plus this length, right? Now this length is what? C. This length is what? A. So A plus C should be equal to this length, that is 2r, plus this length. Now here we can use the distance formula. So that's C minus A whole square plus 4r square. Okay. Now A plus C minus 2r whole square is equal to, I just take this side, C square plus A square minus 2AC plus 4r square. So it's A square plus C square plus 4r square plus 2AC minus 4AR minus 4RC is equal to C square plus A square minus 2AC plus 4r square. Though you don't have to write it once again. Okay, you can cancel it from here itself if this step is not at all required. So it's A square C square A square C square, 4r square is 4r square. This is 2AC, this is 2AC. So 4AC is equal to 4AR plus 4RC. So R is equal to AC upon A plus C. So that is the radius of the circle. So a simple funda we have used over here for any quadrilateral. If it inscribes a circle, that means sum of opposite sides must be equal, right? That means sum of this side should be equal to sum of these sides. Okay, I hope you are clear. Friends, let's say this problem. A square inscribed in a right angle with legs A and B has common right angle with the triangle. Find the perimeter of the square. First of all, I just draw the diagram. Now here's the diagram. The length of legs is given as A and B. So this is A and this is B. Now this is a square. This is X. I assume the side to be X. So this is X, right? Now this length will be what? B minus X. And this length complete is A. So this length will be A minus X. Now obviously this triangle and this triangle will be similar. This angle is 90 degree, this angle is 90 degree, and this angle is equal to this angle, right? So that means if these two triangles are similar, that means B minus X by X perpendicular by base is equal to perpendicular by base. Okay. So A minus X into B minus X is equal to X square. So AB minus AX minus BX plus X square is equal to X square. So X is equal to what? AB upon A plus B, right? That is the side of the square. Now we want the perimeter, just multiply it to 4. So 4AB upon A plus B is the perimeter of the square. Okay, I hope you are clear. Now let's try this problem. In a parallelogram ABCD, angle BAD is pi by 3 and side AB is 3 cm. The bisector of angle A cuts the side BC at point E. Find the area of triangle ABE. First of all, let's draw a diagram over here. Now friends, angle BAD is given to us as 60 degree, right? And sum of this plus this should be 180, right? Because these are interior opposite angles, so their sum must be 180, right? So this is 60, so it should be 120, right? Now what is happening over here? AC is the bisector, that means it is bisecting the angle 60 degree, that means we are getting two angles of 30 degree. Now this angle is 120, this is 30, So this should also be 30. So the sum of the three angles should be 180 in a triangle. Now if it is 30 and the length of AB is given as 3, that means the length of this will also be 3. Now we have to find out the area of triangle ABE. Now what can be done? Now it's very simple, friends. We have used sine formula various times to find out the area of a triangle. Here for the I'm using that only. It's half this into this and sine of this. So 3 into 3 into sine 120 degree. Okay. Now what sine 120 degree is? Sine 90 plus 30, that's cos 30. Cos 30 is root 3 by 2. Okay. So it's 3. 3s are 9, root 3 by 4. Okay. I hope you are clear.